Hey everyone, welcome to section 4.7 in the book. Now we're going to be taking a look at graphs of quadratic functions. So remember in chapter 3 we talked quite a bit about working with them, but we haven't actually talked about graphing them. So where I want to start here is with example 1. So we're going to evaluate these 5 x values. We're going to create a table for the two functions that I'm going to give you. So what I want you to do is I want you to make a table for each one of these. So we'll just go ahead and set it up. And you're going to plug in these 5 values both times. So I'm going to plug these in to this function here. And then you want to plot the points. And then you want to do the same thing here. So you're going to set this up. Same values, -2, -1, 0, 1, 2. So plug these now into this function and then plot. So pause the video, go ahead and do that. Hit play when you're ready to check all your solutions. Okay, so if I plug all this in, so these are all going to end up being positive, right? Because it's going to be -2 squared, so that becomes positive. So this will be 4, 1, 0, 1, and 4. So I'll go ahead and graph these. Let's see, 2, 1, 2, 3, 4. And okay, so there I've plotted everything, so there are my points. So this looks, we've seen parabolas, right? So now we just connect everything, and that looks like it's a parabola shape. Mine went a little wonky over here, sorry about that, but you guys kind of know the idea of this. And let's go ahead and just graph this other one. So this one's going to be a little harder, right? Because now I've got to plug it into this. So let's see, I'm going to take -3 times -2 squared plus 2. So now I just want to use the order of operations here. So this will be -3 times 4 plus 2. So if I plug all of that in, this will be -12 plus 2. So this equals -10. Let's see, I'll do that again for -1. So let's see, this will become -3 times +1 plus 2 by the order of operations. So this will be -3 plus 2. So this will equal -1. At 0, this will be 2. And then I guess at 1 and 2, these will actually be the same values. So, okay, so there's kind of everything that goes with this. So again, you just want to be careful with the order of operations. And if you're like, why is it that this is positive? So whenever you plug in numbers, you always put parentheses around it, and then whenever you square a negative that's in parentheses, it goes back to being positive. So that's just a quick overview with that. So let's see. So looking at this, so I don't think I have enough tick marks here. So let's see, I have 1, 2, 3, 4, 5, 6, 7. I don't have enough tick marks. So what I'm going to do is I'm going to count each tick mark now as 2 in each direction, just to help me out with this. So let's see, I have -2, -10. So -2 would be right here, and then this will be 2, 4, 6, 8, 10. So there's my first point. Oops, yep, -2. And then -1, -1. So that's actually going to fall just in between here. So I've got to kind of approximate. Oops, sorry about that. Approximate. Oh my gosh. 0, 0. And then 0, 2 is going to be up here. And then it's going to be symmetric on the other side. So it's a little bit more compressed, but we got to do what we got to do for this scale. Okay, so there's my other quadratic, or my parabola. Okay, so now that we've done that, now we can actually look at the other part of this question, which says, determine what the vertex, axis of symmetry, domain, and range are from the graph. Okay, so the vertex, remember the vertex is either the highest or lowest point. So the vertex, I'll just highlight it in orange here. So here's the vertex here. So my vertex here looks like 0, 0. And then the axis of symmetry is the invisible line that goes through the vertex that would perfectly cut the parabola in half. So if I do my axis of symmetry in pink here, so here would be, hopefully you can see this line, maybe I'll make it a little thicker. Here's my axis of symmetry. So my axis of symmetry, so you always just use the x coordinate to get you to this. So it's just going to be x equals 0. So it's x equals whatever the x was from the vertex. That's the long and short of it. And then the domain and range. So we've talked about domain and range before, but I realize we might be a little bit rusty here. So The domain is whatever the x values can be, and the range is whatever the y values can be. So, looking at the domain, okay, so remember, the key with this is to try not to overthink this too much, which can be a little bit tricky. But here's the thing. When I look at this graph, so notice that it's kind of going out on this slight diagonal in each direction. So you want to try not to overthink this, and this is always the hardest part with this. So the domain in this case is going to be, it's just going out this way, so the x values, from our perspective, we can't see any reason why they wouldn't just keep going out kind of in this general direction for forever. They appear to be doing so very slowly, but they're going out on this diagonal, so they're just going to keep going out on this diagonal for forever. So the domain in this case, the domain, see, I'll use the black color now. My domain, this is going to go really from negative infinity to positive infinity. So, in other words, it always just goes to the left and right forever. Now compare that to the range. So here's where the range really will start to maybe make a little more sense. How can you tell where it starts and where it stops? So the range is the y values. So as I look from the bottom to the top, there's a really clear starting spot for the range. There's nothing here, nothing here, nothing here, nothing here, and then boom, there's my first y value. So that's what you're looking for when you're trying to determine domain and range. It has to be this very clear starting and stopping point. With the x's, like when you look at this, you might think, maybe like in the back of your head, you're like, oh, I could make an argument though. It doesn't look like it's going to cross this line or whatever. But you don't have some very clear piece of information giving you that. Versus with the range, it's really, really clear. It starts here. So that's what you're looking for when you're trying to come up with like domain and range, and that's what I kind of mean about trying not to overthink it too much. You are looking for these clear signs. If you don't see the clear sign, then don't try to make it that way. So in this case, when I go from the bottom, nothing, 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 and then here's where I start. What is this y value? It starts at 0 and then it just continues on up forever. So the range in this case, then that's exactly what I need to reflect. It starts at 0 and 0 is included. So since 0 is included, it gets a square bracket and then it just continues on for forever. Now, one other thing just to remind you of, infinity always gets the round bracket, and you use a square bracket when you want to indicate that a value is included. Okay, so now let's pivot to this other one. So let's talk about vertex. So the vertex is right here. So we already said this was the 0.02. The vertex is the 0.02. And then the axis of symmetry is the invisible line that cuts the parabola in half. So this would be actually just the axis of symmetry is going to be the same thing as before. It's still x equals 0. So it's always just x equals whatever the x coordinate from the vertex was. So that's like a clear thing to pick out. Okay, so now domain and range. So the domain, so notice this is exactly like the other one, right? Again, all I can see is that this is kind of going out on the diagonal. So I can't impose like, oh, I think it's going to stop here or whatever. I can't impose that. I don't have, like the hardest thing I think with this is to try to stop your brain from imposing rules on it. I don't see any reason why it would stop going this way. Maybe I kind of feel like it should stop going, you know, out to the diagonals, but I don't have any evidence of that. So because of that, my domain is going to be the exact same as before, but now my range is going to be very different. So range always goes from bottom to top, okay? So starting from the bottom, well, hey, I have all of these values down here, and then my range actually stops here, right? So I've got tons of y values, y values, y values, and it stops. So now what I actually need to do is I need to kind of reverse it. So since the range is just continuing down this way for forever, we actually say it starts at negative infinity, but then it continues all the way up until 0. Has a hard stop at 0, right? So you always go from smallest to largest value. If you're going down this way, this is the negative infinity direction. If you're going up this way, this is the positive infinity direction. For the x's, this way is the negative infinity direction, and over here is the positive infinity direction. Okay, so just a little more review I want to do in this part of the video. So the other thing I want to review with you is the vertex formula. So the vertex formula looks like this. We totally talked about this before on page 282. So this was a chapter 3 thing. So this is the vertex formula, and you use it for a quadratic function of this form. So what I'm going to do is I'm going to show you how to, I'm going to review how to do this. And then I'm going to also show you how to graph now a parabola based off of the vertex. So I'm going to kind of give you all the details here. So the first thing that we want to do is when you look at a quadratic, so I've got 2x squared minus 4x minus 1. First I want to just identify what's my a and b. So my a is 2 and my b is -4. So that's just lining it up with this equation here. Okay, so now I need to first identify this negative b over 2a. So I need to figure that out. So my negative b over 2a, if I just plug all this in, this will be -4 over 2 times 2. So this really becomes 4 over 4, so this equals 1. So this was the first part of finding the vertex. And then you plug this vertex back into the function. So I need to plug this 1 into this now. So I'm going to plug in f of 1, and this becomes 2 times 1 squared minus 4 times 1 minus 1. And now I just work this out. So this is going to be 2 minus 4 minus 1. This is really 2 minus 5, so this equals -3. So that means that my vertex then, I have to use the 2 points. My vertex, here was the x point, and now here's the y point. So my vertex is 1, -3. Okay, so now what I want to do is I need to use this information, and then I'm going to use this information to help me figure out whether or not, I'm going to use this information to help me graph the quadratic. So I go to 1, -3. Now, the next thing I should be able to do is determine whether this vertex represents a maximum or a minimum. Now, if you forgot what that kind of means, or why are we talking about this? So remember, this example here actually illustrates kind of the two things that can happen with parabolas. Parabolas either open up or they open down. So here, in this case, the vertex was a minimum, and here the vertex was a maximum. So a vertex will either be a minimum or a maximum. And so I'm just doing a whole bunch of review right here. If you go back to page 282, we actually talked about the way that you can identify whether or not a parabola will open up or down. It has to do with the leading coefficient. So in this case, if the leading coefficient is positive, then it will open up. So maybe I'll just note that here. If a is positive, so if a is greater than 0, the parabola opens up. If a is less than 0, then the parabola opens down, and from there you can actually figure out whether or not you have a maximum or a minimum. So this is a nice little visual to help you. So in this case, this parabola will open up, right? My a in this case is equal to -2. So I'll write this out. My a equals 2. So that means the parabola will open up. Or we could say that the vertex is a minimum. It's kind of the way you can think about that. Okay, so now I know I'm like throwing so much at you here, so we're gonna do several examples of this just to kind of get you used to all this information. Okay, so I know that this is supposed to open up from this point. This is going to be the lowest point right here. The vertex in this case represents the lowest point. So now the next thing that you want to do is you want to determine what does this actually look like. So from this point here, you basically now want to choose a point to the left and to the right of it. And so I'm suggesting actually that you choose 2x values on each side of the vertex. So let's start with, here's my vertex. Let's choose 2 values on the left side. So you don't have to go crazy with this. If here's where my vertex is, now using this as my visual cue, let's choose a point over here. So if I choose this point over here, so I don't know what the point actually is, right? But if I just choose an x value to the left of the vertex, so 2 left values of the vertex are going to be x equals 0 and x equals -1. So you're literally just looking at your vertex and then saying, okay, what are just 2 values to the left of this? And now I'm going to figure those out. So I have to plug these in. We'll do that in a second. We'll organize all that in a table. Then what I want to do is I want to choose 2 right values of the vertex. Okay, so here's my vertex. So now if this is where my vertex is, just what are two x values to the right of this? Well, this would be x equals 2 and this would be x equals 3. So here are the two other x values. So you're going to use the vertex to help you determine two values to the left and to the right. And now what I recommend that you do is you use a table to help you figure this out. Now I'm running out of space here, so why don't I erase this and then we'll make a table. Okay, so I'm going to take these values and plug them into this table here. So I'm just going to go in order, -1, 0, 2, and 3. So here are the values I want to plug in now to this function. And so if I work that out, so let's see, if I plug in f of -1, so I get 2 times -1 squared minus 4 times -1 minus 1. So this will be 2 plus 4 minus 1, so this one will equal 5. Then if I plug in f of 0, so this will give me 2 really times 0 minus 4 times 0 minus 1, so this will equal -1. So there are my two values on the left. So now let me choose my two values to the right. So now let's evaluate f of 2. So at f of 2, this is, oops, I think you can't see me now. This will be 2 times 2 squared minus 4 times 2 minus 1. So this will be 8 minus 8 minus 1 is what that will work out to. So this will equal -1. And then finally, if I evaluate f of 3, 2 times 3 squared minus 4 times 3 minus 1. So what does this equal? So let's see, this is 18 minus 12 minus 1. So that will be 5. Okay, so now I've figured out my left and my right values of the vertex. So now I already plotted my vertex, and now I want to plot these other values. So I'm going to go to 0, -1, so there's that. And then I've got -1, 5, so here's -1, 1, 2, 3, 4, 5. So I've just checked off these points go with these points here, okay? Now let's go to the other side. So I need to mark 2 -1s, so right there, and then 3, 1, 2, 3, 4, 5. So there are my other values. So there's my ones on the left. So I've gotten those two now. Okay, so we knew that this was going to be a parabola because this x is squared. That's a key that that's going to be squared. So now all I have to do is connect the dots, and I know that this is going to be the lowest point, and there you go. Okay, so I realize it's a whole bunch of work to kind of figure that out, and once you kind of get a sense of what you're doing, I think it goes a little bit more smoothly. I think this is a good place to pause the video, and then we'll do some more of these in the next video. So I'll see you guys in the next video.